Let theta be the angle between the unit vectors a and b. Express the magnitude of a vector minus b vector in terms of sine of theta over 2. Let's review firstly how to find the vector which is the sum of two vectors and the difference of two vectors. To find the sum of two vectors, for example a and b, two vectors must start at the same point, and notice that if you move some vector parallelly, it remains the same vector, its coordinates remain the same. So if two vectors start at the same point, you draw a parallelogram, and the diagonal is a vector which is the sum of two vectors a and b. Another rule for the sum is triangle rule for the sum. You need the next vector must start where the previous ends. So you should move b parallelly so that it starts where a ends. And then you connect the starting point and the end point, and it's a vector which is a vector plus b vector. And you may add absolutely any number of vectors using this triangle rule for the sum. And let's consider a regular hexagon A, B, C, D, E, F, and for example AB vector is A vector, CB is B, and DC is C vector, and question is to represent FD vector in terms of ABC vectors. How it works? You choose any connected path, for example in this direction, and you move from the starting point from F to D, and FD vector is FA vector plus AB vector plus BC vector plus CD vector. And you can see that FA is parallel and of the same length as DC vector, and it's directly C vector. AB is given, it's A. BC, we need BC, but CB is B vector. We need the same parallel vector, but it's just in opposite direction, of the same length, but just in opposite direction. So we just plus negative B or just minus B. Plus CD, and also CD, you can see that it's negative C or minus C, and you can see that it's A minus. Or we can move in this direction, and you can see that FD is also FE plus ED vectors, and FE you can see it's minus B, and ED it's A, and you can see that it's the same. And for the difference, two vectors A and B must start at the same point, and we connect endpoints, and if this vector is directed to A, it's A minus B vector, and if it is directed to B, it's B minus A vector. And it is given two vectors A and B, and we need magnitude, or it just means that length of this vector. How to find it? We can consider corresponding triangle constructed on given vectors, and the length of the corresponding side will be equal to the length of the corresponding vector. And it is given that A and B are unit vectors. Unit, it means that length of A vector is 1 and length of B vector is also 1. So it looks like this: 1, 1, and it's A minus B. Magnitude is required. You may denote it as X. And also it is given that angle between A and B is theta, so theta is here. And how to find this length? You may use cosine rule directly. Formula is given in a data booklet, and it says it: sine squared is equal to the sum of squares of two other sides minus 2 times these sides times cosine of the angle between them. But we need in terms of sine of theta over 2, so we should use what? Double angle formula. And I don't remember it. You may use directly from data booklet, but I remember that cosine of 2x is cosine squared x minus sine squared x, and cosine squared is 1 minus sine squared, so it becomes 1 minus 2 times sine squared of x. And if we choose 2x to be theta, you can see that this angle must be 2 times smaller, so cosine of 2 theta, oh no, cosine of theta is 1 minus 2 times a sine squared of theta over 2, and substituting it, we get that a minus b magnitude is square root of what? 2 minus 2 times 1 minus 2 times sine squared of theta over 2. And let's just expand. It becomes square root 2 minus 2 plus 4 sine squared of theta over 2, and it becomes what? Square root of 4. It's 2, and square root of sine squared. In general, it's sine of theta over 2 and the absolute value. And you remember that the absolute value is just a number. Let it be x. Is just x when x is positive, and negative x when x is negative. And what about a sine, I mean plus or minus of sine? Since theta is in between 0 and pi, it's 180, theta over 2, it's in between 0 and 90 degrees, and it's the first quadrant, sine is positive, so as theta over 2 is greater than 0 and less than pi over 2, finally a minus b magnitude becomes 2 times sine of theta over 2. Another method, you can notice that an isosceles triangle arises here. For cosine rule it doesn't matter actually, but if you consider just a half, if you draw a height to this side, which is the required, and if you consider a half, since this height is also a bisector, this angle becomes theta over 2, and this is also theta over 2. And if we consider a half, you can see that it becomes like this. Hypotenuse is 1, this side is the required, but it's half, and this angle is directly theta over 2, and you can just consider what? Just sine by definition. So sine of theta over 2 by definition, it's what? A minus b magnitude over 2 divided by hypotenuse by 1. So let's write like this, half of, like this, a half of a minus b and divided by 1, and hence a minus b magnitude is just 2 times sine of theta over 2. This way is much easier and much quicker. And that's all for this question.